today we do the 4 code challenge. So let's see 4 question from the lead code. First question is step to make an array non-decreasing. Second one is a array prototype last. Third is fraction addition and subtraction. And fourth one is a longest subsequence with a limited sum. Okay, let's see. Let's try to solving the first question. Easiest one, the longest subsequence with limited sum. What the question was trying to say that let's copy. Okay, you can so you are given an integer array nums. Okay, we have to first copy the question. Let me copy this question. Okay, till here. Okay, document. mm, 4 code challenge. After that we have to place this question. Okay, till here everything is okay. So both let's see. So you are given an integer nums, so we have nums integer nums array of integers. Okay, and of length n. Okay, and integer array queries of length m. Okay, return an answer of length m where answer of I represent what is the maximum size of subsequence that you can take from nums such that the sum of its element is less than is equal to query of I. Okay, answer of I represent that the sum of the element is less than sum is less than queries of I. Okay, clear, everything is okay. A subsequence is the array that can be derived from the another array by deleting some or no element without changing its order. So we know the meaning of subsequence. So okay, let's see an example. We are given with the nums array. We are given with the nums array. What is nums array is given at nums array is containing a value of 4, 5, 2, 1. Okay, and queries are given as 3, 10, 21. Okay, the answer vector of the size of this one, size of n 3. Okay, answer contain only this one. So sum of the subsequence whose sum is less than 3. So less than 3. Maximum size we have to represent maximum size you can take from the num. So for the value of 3, how we make less than is equal to, so we only see 2 and this 2, we see this 2 and this 1, the sum is equal to 3, which is less than or is equal to the query of I. So we can take this one. So okay, so the size is 2. After that we have to see the sum of the array, sum of the subsequence which is less than 10. So 4, 5, 4, 5, 9, 10, 4, 5 and 1, and so its answer will be 3. Okay, value less than, so all the values are less than something. So okay, let's try to solve this question. Let's try to the constraint are small. Constraint are small, so we can solve this question using brute force or simply n square. So what we have to do, we have simply check this question. So try all the subsequent question, solve using dp. So wait for 1 second. So to subsequence, so write how we write the subsequence. So simply subsequence generated by taking or not taking, including the value or not including the value. Okay. mm, so in that case we have to return the size. Okay, then longest subsequence. This question is, the topic will be backtracking. Okay, backtracking. Oh, not backtracking. Let's think. So let's think how we make the answer array subsequence, that there is no need of sorting. mm, the one of the brute force approach will be like this. Brute force approach will be, we have to generate all the subsequence, all every time we generate all the subsequence length and check the value. If it is less than, we take the count. Okay, so this will be little bit confusing. What we have to do is simply what we have to do, we make a prefix, do prefix sum. Okay, so this one 0, 4, 9, 11 and 12. Okay, till now the value is 12. So we have to check. We also say suffix sum 1, 3, 8, 8 and 12. Okay, prefix sum which we make out. Longest subsequence, so 4, 5, 2, 1. So how we get 4, subsequence sum. Mm, mm, to the power something, to the power something. If we use backtracking, okay, backtracking. So we are given 4, 5, 2, and 1 at every index. If we have to choose or not choose, so it will take to the power n. So this is not a good approach. So let's think different one. Hmm, how we approach this question? Let me charge my laptop. So longest subsequence. Longest subsequence. Longest subsequence problem. The key idea is you have to. What if? Hmm, subsequence with the limit. Let's try to solving this question. Okay. One of the idea is so the goal of our problem as we have to the goal of our problem is for each query value we have to select the maximum number of the element. Okay. So such that the sum is less than is equal to the sum is less than the query value. Okay. So first of all what we have to think we do sorting. So sort the value. So sorting will be done by nums dot begin and nums dot end. Okay. After that, after sorting, why sorting? Because picking the smaller number first give the maximum number of the element under the sum limit. Okay. Picking the smaller number, picking the smaller number so that we get a maximum length, maximum number of element within the sum limit. Okay. Sorting will be done. So and convert this array into the prefix sum array. So what we have to do? Basically, simply we don't use extra in place in we do in placing in place of something. So for the prefix sum, we simply starting from the 0, okay, and I less than nums dot size, okay, nums dot size or I plus plus, okay, and for that we have simply nums of I is plus is equal to what, and nums of I minus minus 1, okay. So we convert the our nums into the prefix sum value. So our result will be 1 3 something, okay. The sum of the first element, sum of the first two element, sum of the first three element, and sum of the all the first four element. So the answer of each query using, so we have to find answer of the each query. We have the count how many number is greater, the upper bound return, and we use a binary search. So in binary search we find the answer. So we also make a answer vector of integer answer, okay. Okay, and we use binary search because the upper bound return the index of the first prefix sum greater than the query value, okay, greater than the value. So and that index give the that match of number is greater than something, okay. Okay, understanding the question. So we have to count. So we have to make a like simply say what the upper bound different upper bound upper bound upper bound return the upper bound return the value the index after which the maximum value is the upper bound value return the index of the first prefix sum which is greater than the query. So 0 1 2 3, that much of length we have to store on the value, and we push into the answer vector and then return. So simply nums dot begin nums dot end, and for what value, for the q, every time we have to put the value, so q of I, okay, q, okay. So add value for the q, okay, and put the value simply put the value and return the answer. Let's try to write the actual code in the compiler portion. Let's resize this one. First of all, sorting. So nums why sorting, because um, we have to maximize the length. So to sorting we have to select the minimum value to came under the limit sum okay value. So nums dot begin nums dot end end, okay. Sorting then, and we do prefix sum to store the value till the element 0, and nums dot size I plus plus. After that nums of I, to start from the one base index, nums of I plus is equal to nums of I minus 1, okay. We fill all the prefix sum value. So after that what we are doing, we have to initialize the answer vector in which we store the answer. After that we run a auto loop and check every time how many number are greater than or less than the query sum value. So q is equal to queries queries na queries, okay. So we have to simply count how many number is greater than something. So upper bound in which nums dot begin and nums dot end. The value is greater than what, q value, and we have to find the index. So simply what nums dot begin nums dot, okay, and this value, the number, the index will be stored in the answer value. So answer value, answer dot push underscore back and return the count. So the value will be returned and simply return the answer vector. Okay, everything clear. Sorting nums clear, nums dot begin clear, one clear, nums dot size clear, everything. Nums of I plus, nums of I minus 1, vector is clear. Auto cube queries we count, nums dot begin, nums dot end, and simply run this code. So upper is not given, upper must be upper. Okay, accepted and submit. Okay, cleared. Let's move for the next question. The next question is step to make array non step to make a non-decreasing. Step to make an array non-decreasing. Step to make an array non-decreasing. So how we do? Let's copy this question. Okay, copy this till this one and put the document portion. Question number 2. Question number 2. What? Let's see. Our streaming is going on. Not. Everything is clear. So second question is because second question is make an array non-decreasing. Okay. So let's break down the second question. So second question simply telling that we have to the step to make an array non-decreasing. So how we do? So all the shortlisted. Okay. So simply let's try to break down. So you are given a zero index array nums. So every time we see that mostly question from the array question based on array nums is given. Okay. In one step remove in one step. What you have to do, you have to remove nums of I, all the element nums of I, remove all element nums of I. In one step what we have to do, we simply remove the nums of I value. Okay, and whereas nums of I minus 1 is greater than nums of I minus 1 value is greater than nums of I. Return the number of steps to perform, make a non-decreasing. So simply we see the number 5, 3, 4, 4, 7, 3, 6, 11, 8, 5, 11. So in how many steps we have to do this one? Non-decreasing mean that we have to make in ascending order. Okay. So how we do? We simply see in step 1. In step 1, the following step are as follow. All the element nums of I where nums of I minus 1 greater than nums of I. So 5 is okay. After that this one is decreasing, so we remove all the values less than this one. So uh, so let's copy this portion. We simply place this value. So in first step, all the values, this one is less than 5, so we simply remove. Okay, and after that 36, all these values are less than this one, so we simply remove. Simply remove. Okay, and this value is also less than 11, so simply remove this value. We left out with the 5, 7, 11, 11. Okay, so how we do? Let's see. How many steps we require? 3 steps. In 3 steps we make a array non-decreasing. So how we do? Let's analyze in which pattern this question is framing. Step to make an array non-decreasing. So you are given with all these things. Remove all the value is nums of I greater than. So if we simply do an order of n 10 to the power 5, this is not an efficient code. So let's how we think, which see the value 5, 5, 3, 4, 7, 3, 6, 11, 8, 5, 11. So how we do? The following step are performed. Mm, mm, perform. What we have to do? Step 1, we on this value, see the next value. So seeing the next value is not that much. Simply we are trying to think brute force approach, like simply a brute force approach work here or not. So if we run the loop from starting to end, this one, so let's see, let's work now. We check nums of, the condition is that nums of I is greater than as compared to nums of I minus 1. So this condition is not satisfying yet. So we move the value of left here. Okay, left here. Okay, if we left, and what about upper bound value? Mm, okay, move here. Left value move here. After that, this value is greater than greater than after this is the reference value. After reference value. For this reference value, we have to check on the reference value this one. So the reference value updating. So we see the reference value updating after all the things are less than something, and after that the reference value updating, all the things are less than our reference value updating. So this one, and another example is equal to next example. Uh, Next example is this one. So how we do? Make a reference value this one, and if we see the number is greater than this one, make it reference value greater than reference value greater than is equal to same. So in this question we don't need any changes to make the array non-decreasing. It's already sorted in ascending order, so there is no need to do this. So what we think and how we approach this question. Let's see, guess. I think this is a binary search question. Let's see. Okay, monotonic stack, and so no, not a monotonic, not a binary search question. This is a stack based question. So the hint is stack based question, and let's try to we take a hint. So how we solve using stack? Okay, okay. So how we use stack? So let's try this using stack. What if let's stack value will like this, but put 5 value. Okay, if greater than push, otherwise remove. Next value, next, next. After that, if we see greater than this value, count 1. No, how we count 1? How we maintain this counter for removing this one, or the number greater than less than? How we maintain the counter? What is the difference between this number value? So this one way 1 2 3 4, and the whole number is 4 plus 3 7 7 plus 2 9 9 plus 2 11. So 11 length value in which we get 4, so there is 7. How we define that this value is extracting from here and here? So let's think. Let's think how we do. um, Till here everything is okay. Stack, monotonic stack, and seeing the greater value, all these things. Stack definitely work. What do we have to do? And one, notice that element will be removed if and only if there exists a strictly greater than in a left of value. Okay, for the each element we have to find the number of round it take to will take for it to remove. The answer is the maximum number of around all the elements. Built an array DP, hold the information where the answer and use stack of the indices. While processing the element nums of I, remove from the stack all the indices that are smaller than this is a combination of stack and DP. This is a combination of stack and DP. Split the array. Okay. So what will be the brute force approach and what will be the mm, mhm, mhm. Mm, First of all, we try to write the brute force approach. The brute force approach it's been clear. Scan the array in the left and scan the element in the left side, left to right. Okay, and find the all element that is greater than something. Remove all the elements simultaneously. Count one step. So if we try to write the brute force approach, so what we have to do? We simply let's write the brute force approach for this question. So okay, first of all, the number of time we have to make this change. So we make a count c and the count is equal to 0. Okay, what and also maintain a counter which specify that we have made a change. If we don't make a change, simply return 0. Okay, so make a true. Okay, while this change portion is true, okay, we simply run the loop. What we have to simply we make the change to make a false. Okay, and create a vector and create a vector in which we store the new nums, all the values. So new nums dot push back. Okay, and new nums dot push underscore back. What is and nums of I and nums of 0. Okay, after that we run the loop and I starting from the 1 less than nums dot size I plus plus. Okay, if our value nums of I minus 1 value is greater than nums of I, okay, sorry, less than our value is less than something nums of I, but where simply we have to push into the new nums. So new nums dot push back all the things nums of I. Okay, and make the change, else in condition we simply make, if we don't see this type of case, so we simply make a change as to we don't change anything, okay. So if change occur at every step, at every step if change occur, if change is equal to true, change is equal to true, so we make changes. So in this case we have to increase the count, okay, and make our nums is equal to new nums, okay, new nums, okay, update the nums and count return the count value, okay. Let's try to see this one is working or not. Let's see any